Really neat question here. Some fish, some dogs, and some children are swimming in a bay, and there are 40 legs in total, twice as many heads as tails, and more dogs than fish. How many fish are in the bay? Well, let's get this information down mathematically. So 40 legs in total. Well, the fish don't have any legs. The dogs have 4 legs. So one dog would have like four, two dogs, there'd be 8 in total, and so on. Actually, if we call the number of dogs D, then the number of dog legs is going to be 4D. And then the children are going to have 2 legs each, so total number of children's legs is going to be 2C, and that is equal to 40. Twice as many heads as tails, so let's figure out um, the number of, so the number of heads is going to be, well, each fish has one head, obviously. So if you have F fish, then it's going to be F heads. And then you're going to add the number of dogs and the number of children. That's going to be the total number of heads. And that is equal to twice the number of tails. So fish have one tail and dogs have one tail. And then finally, we see that D has to be greater than F. Okay, and somehow we've got to combine this to work out what F is. Well, I'm going to first of all look at the second equation. So F plus D plus C is actually equal to 2F plus 2D. And that means I can subtract F and D from both sides, and it's going to be that C is equal to F plus D. So the number of children is equal to the number of fish plus the number of dogs. Now we have a little bit of information about that the dogs are greater than F. So what I'm going to do is take this equation and eliminate C. So it's going to be 4D plus 2 times F plus D, because that is the same as C, equals 40. And I'm going to expand this. 4D plus 2F plus 2D equals 40. Therefore, 2F plus 6D is equal to 40. And now I'm going to divide by 2, because there's a common factor of 2. In fact, I could have done it earlier on. Could have divided by 2 here. But at least at this point, F plus 3D is going to equal 20. Okay, and finally, actually, we've got an equation with just F and D in, and they must both be whole numbers. They must both be positive whole numbers. And there's one other thing, we've got to have that D is greater than F, because this is actually a Diophantine equation. Yeah, because we're interested in integer solutions, essentially. So there's going to be lots of solutions. D could equal 3, for example, and F could be 11. But we need D to be greater than F. So when I did this, I just tried some until it sort of worked. I could have D equal to 5 and F equals 5. No, that's not going to work. All right, what about D equals 6? Then I'll get 18 and F can equal 2. So with 5, I had 5 and I ruled that one out. When D is 7, I'd get 21 and F would have to be minus 1. And therefore, I've got my answer. F is going to equal 2. Now the answers they show it another way. It's quite nice. I'm going to talk about it, but actually, there's nothing. The process is very similar. At this point, I just substituted some numbers in, and I found that there's a pair that work. And actually, I'm quite convinced that there's not going to be any other pairs. But the answers kind of took it a little step further, and they said, right, because D is greater than F, that means that 4D is going to be greater than 20 because if I replace F by D, it's going to be bigger than 20. So then that's going to give me 4D. So we can see that D is going to have to be bigger than 5. However, we can also see, because I'm adding F to 3D, then it must be that 3D itself is less than 20. And that means that D is going to be, well, it's going to be less than 7. It's going to be less than or equal to 6. And in fact, that kind of shows it a bit more convincingly why there's only going to be one answer for D and hence one answer for F. So, big fan of this question. Hope you enjoyed it as well. And yeah, a bit of fiddling around with these things, creating a Diophantine equation, all good stuff.